Lauren. Okay, so I think it's 1:04, so I think we can probably get started on the actual badge itself, or the patch, I'm sorry. So I have our Weird Science. You didn't need to print this out. This is the one that we got off our website. We have a ton of different patches on there with different ways to earn them. So I'm going to start by reading our opening, and then we'll get started on the fun part, which is the actual experiments. Okay, so do you love conducting experiments? Are you fascinated by odd and weird things? Bring out your inner mad scientist while you experiment with weird science and earn this fun patch. So we are going to discover, connect, and take action to earn this patch. To discover, we will research weird science experiments you can do at home. So the ones that we're doing, I have some facts about why the reactions are happening. So we'll go through that together. But we will also be linking in the comments a link to Carnegie Science Center has all different kinds of activities on your website that you can do at home, on their website that you can do at home. And I think we're linking another YouTube channel that has all different kinds of science experiments and all different learning opportunities. So when you're done with this, if you want to do some more, feel free to click those links, or if you just Google search weird science experiments, there's plenty of stuff out there. And then they also said our patch programs can be found on our website at GSWPA.org/patch program. So if you want to see what Girl Scouts is all about, or if you want to do some more patches, they're on our website as well. Absolutely. Okay, second is to connect. So we're going to get weird and start experimenting, Yay! Which is the most fun part. We have all our supplies set up behind the camera here. And our last step will be to take action, which is just to share your experiments with your family and friends. So hopefully you have a friend or family member with you to do it with you. If you don't have one now, you can test it out, and then we recommend doing a science show for your family members that are in the house with you when you're finished, so you can show them what you learned. So those are our 3 steps for today: to discover, connect, and take action. We're going to be doing 3 different experiments today. If you don't have all the supplies for them, perfectly fine. You can do 1, you can do 2, you can do 3. You can do a totally different experiment when we're done with what you have in your house. But we're going to show you all 3, but by no means do you have to do all 3 of them. Okay, so I think we already went over to go online to find more science experiments. So you can get started with the actual experiments. Yes. Okay, so the first experiment we are going to do is we have a little cup of vinegar. I have it in a measuring cup, and an egg. It's a raw egg. It isn't hard boiled, just a plain egg that we had in our refrigerator. And we are going to put it in our vinegar. You should start seeing it has some bubbles coming off of it. Make sure it's completely covered. I'm going to add a little bit more vinegar so that it's covered. Smaller one. You want to hold that up? Yeah. Or maybe we can tilt this down a little bit. Okay. I don't want to block your face. So you're just going to cover your egg in vinegar. And this one is a little, it's not as exciting because you have to let this sit for 24 hours. How much vinegar? Just make sure it covers the egg so that the egg is submerged in the vinegar. But does anybody, can you type in the comments what you think will happen in the next 24 hours? What will happen to the egg? Thank you for holding. You're welcome. Does it matter what type of vinegar? I have distilled white vinegar, but I think any vinegar will do. The experiment just says vinegar. Someone said bouncy eggs. Bouncy eggs. Mm-hmm. Anybody want to elaborate? You can use apple cider vinegar. The egg will get squishy. Yes, it usually will. The egg will get bouncy. Anybody know why? The girls think the vinegar will eat away at the shell. That's absolutely right. Awesome, guys. Really smart. The shell will disappear. Yep. There will be foam all around it. Yep, that's going on right now. You can see the little bubbles coming off of it. Maybe not in ours, but you should be able to see it in yours if you have it. The shell will dissolve and it will bounce. Yes, I love, oh my gosh, you guys are so smart. Girl Scouts are so smart. Kids think they have a brown egg and they think it will lose its color. I actually don't know, but let us know. Yeah, send us a picture in the comments. I wonder if it will lose its color. Egg shell will dissolve, leave a residue holding the fluids on the center after the center is liquefied. Oh my gosh. We'll break the shell. The shell will go off. Okay, so I think we've covered it. So I have a list of like science facts that I looked up for these experiments that explain a little bit more about each of them and why they're happening. So this comes from Indianapolis Public Library. Vinegar is an acid. Eggshells are made of calcium carbonate. If you soak an egg in vinegar, the eggshell will absorb the acid and break down or dissolve. The calcium carbonate will become carbon dioxide gas, which will go into the air, which is those little bubbles that you see already coming up. What is left is the soft tissue that lined the inside of the eggshell, and it will bounce. So I actually did this yesterday. So I have an egg that I put in vinegar overnight. Let me pick it up here. So this is my egg that I put in overnight, and to you guys it might look pretty similar, but if I squish it,
there you go.
It's she can tell you.
I can attest.
It is
squishy. There's no shell.
There's no shell on it. It's really odd, but the shell has dissolved and the egg that's left is very squishy. Kind of cool. I think it'll bounce. Can I touch it? Will it bounce? I don't want to break it. Ooh. There it goes.
It does bounce. I wouldn't do it from.
Touch it.
Thank you. Ooh.
It feels really strange.
Yeah, it doesn't feel like, if you think it would feel like a hard-boiled egg, it doesn't feel like that at all. It feels like nothing I've ever felt in an egg before. Yeah, I think it will bounce from like a low distance, but if you bounce it from too high, it's going to make a mess.
It'll definitely still break.
Whoa, it's so cool.
Yeah, around 24 hours. You want to keep it in the vinegar for 24 hours. I don't know what will happen if you leave it in longer than that. But start with 24 hours and then put it back in and see what else happens.
Yeah, you guys definitely have to try this at home because I can't explain the feeling.
Someone's asking if you can eat the egg after.
Ooh.
I wouldn't recommend it, but I don't know.
It's a good question.
Somebody
cut it?
Let us know if you know. Is it edible? I don't know. That's a great question. Somebody will let us know. Very bouncy.
Can you cut it? Someone asked if you can cut it. Like, what's on the inside if you cut it?
It's the same. Like the egg is the same on the inside. Like if I cut it, it's gonna be like the squishy. Like the yolk's gonna come out. Oh. Yeah. Okay, some residue is starting to come off. So I'm gonna put that one away. Yes, it gets bigger. Somebody said it gets bigger. Yeah, it absorbs some of the vinegar. So I'm gonna say maybe don't. Like it probably has a ton of vinegar in it. I don't know. I would advise against
I think
it.
it's also
the
still
yolk
raw.
Is still in there.
It's not cooked, so it's probably not safe to eat.
Yeah. Probably not.
How strong is the vinegar smell? Pretty strong.
So do we want to move on to our next experiment?
Yeah.
So for our next experiment, you're going to need like a shallow container. So I have this one, and I have just a thin layer of milk, which is that white liquid in there. It's hard to see. Maybe if I put it in front of your black shirt.
Yeah, that's better.
It's just a thin layer of milk in a container. And then you will need some dish soap, some Dawn. It doesn't have to be Dawn. Any dish soap will be fine. I think hand soap will work too, but it does call for dish soap. And then we have some Q-tips. So I'll give you a couple. Give me a couple. And different colored food colorings. Ooh, ooh. Green, blue, yellow, and red is what I had at home.
I'm excited for the blue. It's my favorite color.
So let me grab the instructions just to make sure I'm doing this right.
Someone said cut the eggs that you used from the knife safety video. Maybe we can do it at the end so we don't make a mess.
Okay, we're going to add 1 drop of red, yellow, green, and blue. But if you don't have the different colors, that's fine too, whatever you have. Close to each other in the center of the pan. Use a cotton swab and put a few drops of dish soap on one end. Take the end and hold it in the middle of the milk for about 10 seconds. Okay, so while we're doing this, you're going to start taking your different food colorings. Drop. You look like twins. We are twins. We're going to do a drop. You want to grab some colors?
Ooh, I can do some too?
Yeah. Don't put it too high like I just did because it's going to splash.
I'm going to do blue.
A few drops of each color.
Anywhere?
It's set in the center,
In
but
the center?
yeah, like close to each other.
Whoa, that one was cool. It's hard for us to show you guys what's happening.
It's like, or maybe you can see it like that. It's like,
but if you're at home and you're doing it on your own,
I think they
it
can
looks
see
really
like
cool. Make sure you do green for Girl Scouts.
It tie-dyes. Yep. Some red.
The blue almost looks black. It's really dark in there.
Yeah. The red and yellow are coming out really good. Okay, so I also have, just for our sake, I have a little container to put our dish soap in. It's hard to see the comments when it's like this, but it'll make a rainbow pattern. So I'm putting just a little dish soap in here so that we can dip our Q-tips in. Just the dish soap.
Someone said if you do this with glue instead of milk, you can peel it off when it's dry and then make a sun catcher. That sounds
Very cool. That is really cool.
You guys can try that at home.
It looks like hydro dipping. Yeah, so I don't know much about hydro dipping, but I've heard of it where you put paint on water and then you can dip something in it and the paint sticks to just that object. Can you repeat the step after milk, please? Yeah, you're just taking food coloring and you're dropping little drops in the center. The color will go out. Yep. What's going to happen when we put, you want to dip your, oh, I get one too. Yeah. So you put your Q-tip, cover it in dish soap. So that's what we have this little container for. Will it smell bad? I think so. I mean, the dish soap smells good. The milk smells like milk. As of right now, I don't know what's going to happen. Will it turn rainbow? Maybe. I've never done this before, so I'm really excited to see what happens too. This one I haven't done yet, so it'll be a surprise for me too. Okay, are we ready to try? Should we? Yeah, let's angle it down. Go ahead, you go first.
Just put it like in the middle?
Yep. I don't know, you couldn't see our faces, but we're really excited.
That was awesome. It all like ran away.
I'm gonna do mine too.
Whoa!
That is wild.
So cool.
So cool.
Can they see it? Can you guys see it?
Yeah, they should be able to see it, but now we can't see the comments. You guys want to see? My parents are coming in because they want to see.
Do you see that?
You might need some more soap.
Yeah, make sure you share this with your friends and family members because it's really cool and they're going to want to see it.
Do it.
Do it again. Here, I'll let Samantha do it.
Wow.
It like runs away.
Yeah. What is that dish soap?
Mm-hmm.
And milk.
Mm-hmm. And food coloring.
That's crazy. Wow, that's cool.
I'm gonna tilt it up so we can see some of the comments. But feel free to keep going. I think you can. I'm sure you can add more coloring to it. Make it your own. It looks like a rainbow flower. It sure does. I think that you might be better off with red and yellow food coloring. The blue and green seem to have mixed to make like a black.
And it'll start like mine started getting covered in food coloring and it stopped working, so you might have to re-dip it in the soap. Someone says that's what happens with germs when you wash your hands. Very good point. Especially nowadays, I got food coloring. It looks like rainbow slime. You can see all the different colors coming out of it. If you just if you hold it down just in one spot,
It just keeps
it keeps
swimming.
going. Yeah, it keeps going around. So if you have this at home, just hold it down in one spot and see what happens. That one was really cool. Someone said it wasn't working for them. I don't know if it has to be I don't know if almond milk would work. I think it has to be cow milk or goat milk, milk. I don't know. If someone knows that, let us know. Will this work with paint instead of dye? I don't know. Give it a shot. It's an experiment. Yeah. Try it out at home. Looks like the Milky Way. Oh, the germ one is with pepper, water, and dish soap. So you could do the same thing with, you take a tin of water and put pepper, and then you do the same thing with the dish soap and the pepper. Yeah. Yeah. I'm sure there's lots of, somebody said they used almond milk and it worked. So if you don't have food coloring and milk, you could do water and pepper and then dip the Q-tip with soap in that, and the pepper will disperse also. And someone's saying try different types of milk and see what happens, see how they react differently. We tried it with almond, coconut, whole milk. We used gel food coloring and it worked. Good to know, good to know. And I'm sure if you don't have everything that you need, Google is great. Google different options that you can use. There's plenty of different ways to do this experiment. Someone said Lauren is having fun. I am. I'm having so much fun. Okay. So I have the reasoning behind why this is happening. So I'll read that and maybe that'll help make a little bit more sense. Unless actually before I read it, if anyone wants to comment and wants to give maybe the scientific reason as to why they think this is happening, why it runs away from the soap. Someone did the pepper thing. Anybody have any? It'll take a second for us to catch up with the comments, but some ideas as to why this is happening, why the colors run away. Something to do with lipids. Fat in the milk is reacting to the soap. The soap pushes away the milk and the food coloring. Someone said chemical reactions. Yes, that is very true. Because they are like a magnet. Yeah, I think it has to do with the polarity. I'm not a scientist. We're gonna learn. Yes, I'm gonna. That's what we're here for. We're here to learn. Yes. If you want to learn more, quick Google search. You can find out all kinds of information on these experiments. Read this one. Baker's food coloring does not work. Good to know. Because sorry, go ahead. I just saw someone said because the milk has germs in it and the soap kills the germs or repels the germs. I'm scared of it. I'm scared. Who are you? The milk fat is reacting to the soap. Milk is a whole different thing than soap. It has a chemical reaction. Okay, so I think we're ready to read the scientific. Yeah, I want to know why. Okay, I want to know why it's happening. So this comes from the Chemical Educational Foundation. Water has a very high surface tension because of strong attractions between the water molecules. Because milk is let me start over. Milk is primarily water, and water has a very high surface tension because of strong attractions between the water molecules called hydrogen bonding.
And because milk is primarily water, it also has high surface tension. In this experiment, the high surface tension of the milk supports the dye molecules on the surface and keeps the dye relatively centralized, which is the tendency to keep a low surface area, minimizes the distance that the dye will spread across the milk surface, so why it was all staying together. In contrast, soap is a surfactant. Would you say that's how you pronounce that? A surfactant or surface active agent is a substance that has the ability to reduce the surface tension of a liquid. Therefore, when a drop of liquid dish soap is added to milk, the surface tension of the milk is reduced. As this occurs, the fat and protein particles in the milk can move more freely and easily. In addition, the soap interacts with the fat and protein particles in the milk, causing the particles to move around. This action can be seen as the dye swirls through the milk.
I gotta read. I gotta keep
Go ahead, you can read it. So it seems like it's all about surface tension, in that when you put the soap in, it breaks that surface tension, and that the particles run away from the soap because it's a surfactant, which is why soap works to clean things. It makes it disperse. And then it also says the soap interacts with the fat and protein particles in the milk. So those of you that were saying the fat in the milk, that was correct. It interacts with them, causing the particles to move around. So whoever in the comments said that the fat in the milk, that is part of it as well. Cool. Someone says they go away because they're trying to social distance. That's hilarious. Awesome. And now it looks like a hodgepodge of colors in our milk. Very cool. Oh, someone says they have fat-free milk.
Oh, that's funny. Maybe that is why it's not working. I have done this before with glue. I want to try it with glue.
I wonder how that works. Okay, the next activity is lava lamp, and someone's asking if they can use mineral oil instead of baby oil. I know it said you could use vegetable oil or baby oil. I think any type of oil will be okay, as long as it doesn't mix with water or vinegar, which is what we're using.
And some people said, what do you do if you don't have food coloring? And other people said use pepper and water. So try that if you don't.
And our next experiment also calls for food coloring, but it's not required. Someone else said they used fat-free milk and it worked. Huh.
We'll have to do some research.
Yeah. That's some good things that we can research to see why that's happening. So do we want to move on to our next experiment?
Yeah, I
feel like we're moving pretty quickly, but they're all pretty easy. Okay, so we need a container. I'm using a mason jar. Make sure it's big enough because there's going to be a little bit of a reaction. You don't want it to spill over. So about the size will do well. I'm also going to need our measuring cup. I have a bucket. Some oil. I just have vegetable oil, but baby oil also works. I think any oil will work as long as it doesn't mix with water. Let me dump this out real quick. You need a lid?
No. You don't need a lid.
But be careful because depending on how much vinegar we put in, the reaction could be pretty big. So if you have we have underneath ours something that you can wipe off easily. And we need vinegar. We have just this vinegar, but any type of vinegar will work. Baking soda. Can you move some of this stuff out? Yeah. I need it now. And food coloring again, but the food coloring isn't required. Okay, so this is called a homemade lava lamp, and I want to see what we think will happen in this one. So the first step is, let's do the first step first, and then we'll go step by step and see what we think will happen for each one. So the first, we need 1 cup vegetable or baby oil and 1/4 cup of vinegar. It doesn't have to be those exact measurements. That's what it's recommending. But if you don't have a measuring cup, just about 3/4 oil and 1/4 vinegar. So I'm going to measure, but you don't have to measure. No, you don't have to do the experiments right now. You can watch us do them, and you can try them later if you want.
Yeah, if you weren't here for the last one, these videos are recorded and going to be uploaded on the Facebook page right after. So if you don't have this now, you can always do it later.
Okay, so I have 1 cup of vegetable oil. I'm going to put that in there into a container. And then we need 1/4 cup of vinegar. So before, I'm going to start measuring this out, but before I put the vinegar in, what do we think will happen? Can you say it again? Yes, 1 cup of oil. Right now you just need 1 cup of oil. Or around about 1 cup. It doesn't have to be exact. And then take about 1/4 cup of vinegar. Again, doesn't have to be exact. Put that to the side. What do we think will happen? Allie and Brooklyn are twin sisters too. Hey, Allie and Brooklyn. And again, it's 1 cup of oil you put in your jar, and then we have 1/4 cup of vinegar. So just in the comments, write what you think is going to happen when we put the vinegar in the oil. The oil will bubble. Oil and vinegar separate from each other. Anybody know why that is? The oil will look like bubbles. Anyone know why the oil and vinegar separate? And the original, if you have the printout of this, the original calls for oil and water and an Alka-Seltzer tablet. So you can do that as well. I didn't have Alka-Seltzer, so I switched it for vinegar and baking soda. It will stay separated. Any ideas why? Paige and Taylor are twins. Hi, fellow twins. Oil is heavier, so it will float. It will float on top of the vinegar. Yeah. Or is oil? I know I have the answer. Actually, I have the answer to that. The oil always floats on top because it is less dense than water. So density. Also, vinegar is mostly water, which is why it is separating, which might be good to note. They don't like each other. Kind of. The oil is less dense. Okay, so let's go ahead and put it in. We'll see what happens. Whoa! It already looks like a lava. It does. So it's separating. You can see there's some bubbles in there. Yeah. Because they're separating from each other. The oil is moving up to the top, and you can already see. Sorry, you can already see the vinegar going to the bottom. And if we let it sit for a little bit, those bubbles will settle. So which one's more dense then, the oil or the vinegar? Oil floats to the top because it is less dense. So water. Okay, so less dense is on the top, right? Yes, correct. So you can see some bubbles on the top layer. And if you let it sit, those will settle. The parents are talking to us while we're experimenting. Very cool. We're about to get to the food coloring, I promise. Well, let's do that if you want to type in some more ideas as to why you think oil and vinegar don't mix. So do we just want to do one color? Let's do green for Girl Scouts. What do you think? Green. And it calls for 10 drops of food coloring. So we'll do about that. You don't need a lid.
Is it gonna get higher though, just so they know?
Yes.
So this is you don't need a lid, but this is gonna bubble up more. So make sure it's not filled to the top because then it'll overflow.
I'm gonna put a couple drops. See what happens to the drop. I don't know if you can see it in there. With my hand. Just pour
I
it on
see,
top
yeah, there's
there.
a little droplet in there. Oh, there he is.
There he is. He's trying to get through that oil. You can also tell that I imagine food coloring is also mostly water, which is why it's
it's dropping.
Drop to the bottom because it is less dense, more dense. More dense.
Yeah, if it's more dense, it goes to the bottom.
Yeah.
So then the food coloring must be more dense than the oil.
Yeah, I think food coloring is mostly water. We'll put a couple more drops in there.
Whoa, there they go. They're
falling?
dropping down. That's so cool. And they're like in little balls.
Yeah, because they won't disperse in the oil. They separate from the oil. So as bubbles, they're separating. Move this up a little bit
so they can see it drop.
Okay.
Here, do you want me to hold it for you?
I think I put enough in there. You can see that all the little dollops of food coloring drop to the bottom. So I think we got a good grasp on why that's happening. So if we want to move on to the next step. Okay, so I have a little cup here, and I put about a teaspoon of water in there. But again, it doesn't have to be exact.
Can I put this down, or do you want me to?
No, you can put it down for now. And then we have baking soda. And I need a teaspoon. I have a teaspoon to measure, but again, doesn't have to be exact. We're going to make like a paste with the baking soda and water.
Someone said, do you mix it? Like, no.
Nope. Just let it sit.
Someone saying, yeah, the drops broke through the vinegar layer, so they're coming down into the vinegar layer
and dispersing in the vinegar because they're both mostly water, so they don't separate once they're in the vinegar, and you can see it like disperse. It's really cool. Do we want to mix it? I think you can.
Mix what, this?
Yeah. So that the vinegar is like colored.
Yeah. It's all dropping to the bottom now and like dispersing once it hits the vinegar.
We'll leave it. Okay. Okay. So I'm mixing my baking soda with my water to make a paste.
How much baking soda?
A teaspoon.
A teaspoon of baking soda
and a teaspoon of water. So just enough so that it makes like a liquidy paste kind of.
So a teaspoon of each.
How much baking soda? It says a teaspoon, but as long as it's like a liquidy baking soda mixture, that's fine. A teaspoon of baking soda and a teaspoon of water. Just equal parts.
Is it equal parts water, oil, and vinegar?
No, so you want about 3/4 of your mixture to be oil and then a fourth to be vinegar. So about again, it doesn't have to be perfect, but about that amount. A couple drops of coloring.
Oh, they're dropping down.
Yeah. And then equal parts baking soda and water. Okay, so now that we have this mixed together, any ideas what will happen when we put the baking soda in the mixture? Any thoughts? If you mix this, it's okay. It's no big deal. Baking soda and vinegar react in a foaming action. It will start bubbling. Mm-hmm. It will make an awesome lava lamp. I sure hope so. We'll activate the bubbles. So what will happen, so we know that when we put baking soda and vinegar together, it foams up and reacts. But with the oil in there, what do you think will happen? It's going to phase, yeah. It's going to rise. Mm-hmm. Jillian, third grade, says shake it up and it goes back to normal. Yeah, so even if you mix this up, the vinegar is going to separate from the oil again and go back to normal. Ella thinks it's going to explode, but not crazy explode. The water and the baking soda will separate too. Mm-hmm. Maybe that's what we should have done at the beginning. We're still learning. We're still learning about Facebook Live. Cool. You may move that. Let me just see the top of my head. We don't want that greenish milk mixture to fall on the floor. We'll bubble and make a lava lamp. That's perfect. Is that good? Yeah. Vinegar will protrude up through the oil. Yep. You guys are so smart. Okay, are we ready? I'm gonna mix this up.
This is a much better way to do it.
We'll know for next time.
Yeah.
Okay, ready? Get everything out of the way in case this rises up more than we expect.
Woo!
Whoops. But now that it's settled down, you can see the bubbles lifting up and down, just like a lava lamp.
I'm gonna get a paper towel.
Sorry, parents, for the mess. The reaction causes the vinegar to lift up and down. It's okay, it's cleaning up. You can see it bubbling up. Pretty cool.
It's okay to make mistakes.
Lawrence, it's okay to make mistakes. I've already done it, and it didn't happen last time. There's just something in the air today. You can see the bubbles lifting up and down.
Do you need any more paper towels?
No, I think we're okay. Can you put a lid on and then shake it? Yeah. I have a lid. I'll be right back. It's not going to explode again.
Yeah.
It just exploded. That's really cool. It was kind of cool, to be fair. How long will it last? I think it'll last a few minutes, but then it'll start to separate again. But we did it the other day, and you can just add more baking soda and water to it, and it'll start doing this again. Right, Samantha? Like it'll settle down, but if you add more baking soda and water mixture, it'll do it again. Lid on. Shake it up a little bit. I know, this idea. Whoa. Going a little bit again, but I think that original reaction between the baking soda and vinegar has settled. So you have to put some more. Oh, someone said we used a flashlight to shine through the bottom of our mason jar. Really cool. I'm doing it. It looked like cotton candy. I'm going to take this lid off and make sure nothing happens when you. Okay. Yeah, if you put a lid on and you take it off, it's not gonna explode. What? Oh, it's too bright. Do it from the bottom. Hold it. You move it down just a inch. My hand's covering it. Sorry. I think it's kind of hard to see on camera. It does look really cool in person, though. Great idea. Great suggestion. Yeah, I like that. Okay, so now that we've done it, can anyone give some ideas as to what they think happened? It does smell bad. It smells like vinegar. It reminds me of dying Easter eggs. It smells like vinegar. Yeah. So, say the question again. Just some ideas. If someone says you can add Alka-Seltzer to it too, yep, that'll cause a reaction. Just some ideas as to what we think is happening in this experiment. Why is it bubbling up like it is? Why is it separating? Someone said we put sparkling flakes into it. That's cool. Oh, that is cool. The vinegar reacting with the baking soda mixes and explodes. Mm-hmm. Someone says very cool, but very messy. There was a chemical reaction. Mm-hmm. Acid mixed with a base. Yes, that is correct. I'll be reading a little bit more about that in a second. The density made that happen with a chemical reaction, the vinegar and baking soda or Alka-Seltzer. Kind of like carbonation and pop. Yes, is this kind of like when you put Mentos in Coke? The vinegar mixture is more dense than the oil, so it sinks, repeats, and rises, repeat. Awesome. A chain reaction, chemical reaction. All great answers. The water separated from the vinegar. It's starting to settle back down now. Yeah. You want to add some more vinegar? Or some more baking soda? Yeah. Okay, you get a little bit more water. So yeah, I know people were asking before, like, how long is this going to last for? It just does it for a couple minutes and then it kind of settles back down. I mean, there's still bubbles moving around in there. But if you add more baking soda and water, you can make it happen again. My cat is here. His name is Puck. You gotta show him. I will. He's busy. Okay. So this has a little bit more water and a little less baking soda, so maybe not as big of a reaction. And we gotta be careful. Ooh, there it goes. There it goes. Not as much baking soda this time, so a little bit smaller reaction. There we go. It's doing it some more. If you shake it, it will go back to normal. Not as cool as this first time. Okay, so I have some explanation for all of this. So this is from Questacon, the National Science and Technology Center, about why oil and water don't mix. But this also goes for oil and vinegar because vinegar is mostly water. Even when you mix oil and water together, they still separate. The oil always floats to the top because it is less dense than water. Oil and water don't mix because water molecules are more attracted to each other than to oil molecules. Molecules of water are strongly attracted to each other because they are polar. Oil and water molecules are not attracted to each other because oil molecules are nonpolar and hydrophobic or water-fearing. So whoever was saying it's like a magnet, it kind of is like a magnet, except they're not attracted, they're separated from each other. Yeah, so like when you put like two magnets together and they push. Yeah. like that, where like a magnet and metal it would stick, just like water and water. Oil and water is like two magnets that push apart. Yeah. Hopefully, making sense. The water and oil don't mix, so the oil floats to the top when you put it in. Awesome, awesome. Okay, so my next explanation is about why baking soda and vinegar react. And this is from wonderopolis.org, which is part of the National Center for Families Learning. So, baking soda and vinegar react chemically because one is a base and the other is an acid, which I know somebody already mentioned, bases and acids. Baking soda is a basic compound called sodium bicarbonate. Vinegar is a diluted solution that contains acetic acid. The baking soda and vinegar reaction is actually two separate reactions. The first reaction is the acid-base reaction. When vinegar and baking soda are first mixed together, hydrogen ions in the vinegar react with the sodium and bicarbonate ions in the baking soda. The result of this initial reaction is two new chemicals, carbonic acid and sodium acetate. The second reaction is a decomposition reaction. The carbonic acid formed as a result of the first reaction immediately begins to decompose into water and carbon dioxide gas. Just like carbon dioxide bubbles in a carbonated drink, somebody also mentioned like soda, or pop if you're from Pittsburgh. Okay, just like carbon dioxide bubbles in a carbonated drink, the carbon dioxide, which was formed as the carbonic acid decomposed, rises to the top of the mixture. This creates the bubbles and foam you see when you mix baking soda and vinegar. So very interesting. There is a ton of explanations out there, more explanations about the reaction between vinegar and baking soda that go into a little bit more detail if you want to learn a little bit more. But that's a very basic explanation of what's happening. So we have a couple of questions. What will happen if you just add baking soda? I think they want you to mix it with water just so it sinks through quickly. I think if you just put the powder in, it would kind of sit on top and it would take a while to get in. I wish it could stay forever. I do. Well, I think with that, you want to grab the other cat?
We have to do this at the end
now
of
we're going to have to do it
video
every
now.
time. Oh, it's okay, bud. You want to meet some friends? Oh, we ran away. He's not as friendly as Queso is. He's a little bit shy. Some other questions coming in. Okay, Queso's coming back because Puck doesn't want to visit. Say hi, Queso. He's not so shy.
We do have two other cats, but Queso
they're
likes
not
to make new
interested.
friends.
Queso likes science. Okay, so with that, with our explanations that we learned all about these science experiments, with testing out these science experiments and thinking about what's going to happen and sharing it with a friend,
Makes it so much more fun.
It really does. We have officially earned our Weird Science patch. We will be linking information in the comments as to where you can ask to get a patch. Or the details, there'll be like an order form in the comments. It'll say Girl Scouts Western Pennsylvania, and we'll put in the comments what you can do to get the patch. But other than that,
Someone said, "Can we cut the egg now?"
Yeah, okay. We already made a mess.
Get a bowl though, so it doesn't go everywhere.
Say bye, Queso. Okay, bye.
Everyone's saying to cut the egg. We are going to cut the egg.
Oh, sorry. That wasn't knife safety. Whoever's at our knife safety.
Is it going to cut? Another explosion!
And it's just like a regular egg inside, but it's extra liquidy because I think it has vinegar in it. And this is what the shell looks like. It's pretty cool. It really popped. And if you guys do like these videos, we're going to be doing more of them. Make sure you share them with your friends if you think that they would enjoy doing it. This is for everyone. So make sure you share with all your friends too. The next one is duct tape. We're going to be doing duct tape fun on Tuesday at 6:30. And then Thursday at 6:30, we're going to be not doing a knot tying match. I think that's pretty much it. If you are watching this and you aren't a Girl Scout yet and you're interested in the stuff that we're doing, make sure to go to our website. It's GSWPA.org, and we have a lot of really great information on there about what Girl Scouts do. He's trying to make his appearance now.
You can see his head.
But yeah, Girl Scouting's for everyone, so make sure you share this with all your friends. We're all about making the world a better place, so we like to share with everyone.
He's right.
Thank you guys for joining us. We had so much fun today.
Thank you so much for joining us.
Thank you for earning your weird science patch. If you have any questions, again, you can always email GSWPA customer care at gswpa.org. If you have questions, you can call. Right now, we are closed for the week, but anytime during the week, you can call too. Put suggestions in the comments, and we will see you Tuesday. See you Tuesday. Thanks, guys.
Have a
Stay
good weekend.
safe.
Yeah.
Have a great weekend. Stay safe.
Stay inside. Get some fresh air though in your backyard.
Wash your hands.
Yes.
Don't eat the egg.
Yes,
Someone
please
said
don't
eat the egg.
please
Don't eat the egg.
Right. Bye everyone.
Bye,
Thank
guys.
you.